Hello and welcome back. Previously, in this course, we looked at an example where a firm produces a single good Q and is interested to identify what is the profit maximizing level of output. For a given demand schedule and for a given cost schedule, we use charts in Excel to eyeball and identify the profit maximizing level of output for this particular firm. The problem, however, could get more complicated, so much so that it might even become analytically impossible to identify what is the profit maximizing level of output. So how do we tackle such a kind of a problem? The answer is we would use solver. Let's now look at a simple example where the total cost curve, the total cost is given by C0 plus C1Q plus C2Q square, where C0, C1 and C2 are fixed parameters. Q is the quantity of output that the firm should produce. The demand curve is given by A minus B1Q minus B2Q square, where again A, B1 and B2 are fixed parameters. Total revenue clearly is price into quantity, and total profits is total revenue minus total cost. And the firm is interested to identify what level of Q for these fixed parameter values maximizes its profits. So let's now look at some arbitrary example where C0 is equal to 100, C1 is equal to 14 and C2 is equal to 1, and A is equal to 300, B1 is equal to 10 and B2 is equal to 1. Let's start by choosing some arbitrary value for Q equal to 10. Price therefore is equal to A minus B1 into Q minus B2 into Q square, and C is equal to C0 plus C1 into Q plus C2 into Q square. Total revenue is equal to price into quantity, and total profit is equal to revenue minus costs. As before, let's click on solver. We need to set an objective, and the objective is to maximize profits, which is given by cell F15. And this objective is maximized by changing the cell Q and subject to some constraint. Now, do we need to choose some constraints here? The answer is, well, we do know that Q must be greater than or equal to 0. For this, for choosing the constraint as Q greater than or equal to 0, the default option here is make unconstrained variables non-negative. This essentially means, in this example, Q is greater than or equal to 0. Alternatively, so we could uncheck this and we could add Q greater than or equal to 0 as a constraint. How do we do that? We just say cell reference Q must be greater than or equal to 0, and we do OK. But this constraint here is equivalent to not having this constraint and having this option as checked. So I leave it to you to not have this constraint and to check this option, which is as it is the default setting, and see whether the solver gives you the same answer. Anyway, so then select a solving method. Well, GRG nonlinear, because this is indeed a smooth nonlinear problem, and let's click on solve. Alright, so the solver has identified some solution. Let's do OK. So the answer here is 6.763, and profits at this level of Q is 1021. Now we can cross-check this. Let's plot this out for these set of parameter values, and let's indeed see or confirm that 6.763 is indeed the profit maximizing level of output. So what do we have here? I have already worked this out here, so as an exercise you should look at a blank spreadsheet and you should actually calculate this entire schedule out. So I've taken a difference of 0.2. You can of course choose finer incremental values. So let's insert a blank chart, select data, let's do add, series name profits, we select the X values and the Y value. Let's click on OK. And indeed, somewhere at 6.8, according to this curve, profits are maximized. So that confirms the solution that solver has given us. We have more complicated problems in our exercises. In the next example, we will look at a constrained optimization problem. So see you in the next video. Thank you.